Okay, so we're starting exponents, unit 5.1, day 1. Okay, so we're going to go over the rules. I want you to realize that nothing today is new. You have learned this stuff, okay? So knowing that, it says rule number 1, the power of 1. Y'all, anytime you have something to the power of 1, it's just itself. You know how we always talk about the 1, like the 1 in front? You don't always have to put it, but you can. Same concept with the power, okay? If you ever have a letter, it always has a power of at least 1, but you don't have to put it, okay? So one thing I do want y'all to realize, so the big number or letter, like A, for instance, is called your base. Okay, we call it our base. Okay, the little number or letter in the top corner, what do we call? The exponent. Do we also call it our power? Yeah. Okay, you can say the power, you can say the exponent. Either way, it's the same thing. Okay, so just a reminder, anytime I talk about the base, I'm talking about whatever has that exponent. Okay, it's whatever the big number or letter is. Yes? Okay, so like here, this is base of A, exponent 1. Obviously, I'm not going to say that. I'm going to say A to the first power. Okay, but just so you know. Okay, so here we have power of 0. Does anybody remember the power of 0 rule? What? It equals 1. Anything to the 0 power equals 1. You can have a million to the 0 power, and guess what it equals? 1. It doesn't matter. You can have letters to the 0 power. It still equals 1. Okay? So if you look at this example, it says p to the 6, r to the 5, and all of that is to the power of 0. What does it equal? 1. Another example, what if you have like m to the 0 plus n to the 0? Doesn't that just give you 1 plus 1? What's 1 plus 1 equal? Does that make sense? Anything to the 0 power is 1. Okay? Now, it says product of bases, so multiplying. Now, do you see how my bases match? They're both A. So when your bases match, you just add your exponents. Okay, and I'm going to prove to you why. So if we have like m squared times, I was about to write plus, my bad, m to the 3rd power, don't exponents just mean how many times you multiply? Isn't that what an exponent represents? So if this is m squared, that's the same as saying m times m, right? Times, because there's this multiplication, m cubed, 1, 2, 3. Well, how many times is m being multiplied? So you just add your exponents, because exponents represent multiplication, so we're just saying how many times we're multiplying, okay? Now, do you have to write it out every time? No. Add them, okay? But if you don't know the rule, could you write it out? Yes. So, looking at example 2, I want you to realize, y'all, numbers without exponents, you treat just like normal. So if there's multiplication in the middle, what do? Multiply. If there's addition in the middle, you add, okay? Numbers without exponents you treat like normal. Now remember, if I don't have a number, I can put a 1. What's 1 times 2? 2. And what's m to the 5th power times m to the 4th power? 9. There's your answer. Okay? Any questions with that? So look at this one. What's negative 3 times 4? Negative 12. Okay, c cubed times c. C to the 4th power. D times d to the 4th power. D to the 5th power. Okay, now this is written properly. If you'll see, it says order to write answers. You always write your number. Okay, our number was negative 12. And it says then the variables, the letters, in alphabetical order. Okay, C comes before D, so we put it in the right order. Yes? Okay, they should always be written in the right order. So it should be pretty easy. But on problems like, not this one, just kidding. Okay, there's one we'll get to in a second. But it has them where it's missing some, so you have to just make sure you write it in the right order. Okay, so on this one, what's 2 times negative 4? A times A cubed. A to the 4th power. C squared times C cubed. C to the 5th power. And then there's just this D left over here. What do I do with that? Just bring it over there. Whatever it is. If there's nothing to multiply, it stays the same. Okay? Any questions with that? Okay, so let's look at what does quotient mean? Huh? Division, divide. Just like product means multiply. Okay, quotient of bases. Okay, when the bases match. Well, if you add when you multiply, what do you think you do when you divide? Subtract. A to the top exponent minus the bottom exponent. Now, instead of using this rule properly, I'll add that word in there, always think about where there are more numbers. So let's look at an example. Okay, and I'll show you why too here. So we'll say we have a to the 3rd power over a squared. Well, 3 minus 2 is what? 1. Now watch if I write it out. This is saying a multiplied 3 times over a multiplied twice. Well, when you're dividing and they match, don't they cancel and become 1? Well, 1 times a is just a. That's why we subtract, because they're canceling each other. Does that make sense? Okay, so here we have x to the 11th power over x to the 5th power. Where are there more, top or bottom? Top. So guess where they're going to stay? On the top, okay, because there's more up there. So what's 11 minus 5? 6. Now, if there's nothing left on the bottom, do we have to write it? No, you don't have to have a denominator. Now, do you have to have a numerator if there's something on the bottom? Yeah, you can't have like an empty top. Does that make sense? Okay, so knowing that, let's look at this one. Are there more on top or on bottom? Bottom, so guess where the end's going to stay? On the bottom. What's 12 minus 9? Now remember, the numerator cannot be empty. So what do you think we put? A 1. There's your answer. So you're still subtracting. I'm not saying you're not using the rule properly. I'm just saying decide where there are more and then subtract in that order. Because if you were to do 9 minus 12, what would that give you? A negative. So we'll talk about negatives tomorrow and you'll see why it's still right. But for now, we're going to do it this way. Yes? Okay, but that's our whole thing tomorrow is negatives. Okay, so we're going to do a couple together. I want y'all to try to start a couple of them while I take attendance. Don't do these. Start 7, 9, and 11. Colby wasn't in last period, right? Okay, never mind. Okay, what are we going to do on this one? Multiply. Multiply what? What's negative 3 times 2? Now, what do I do? Multiply / add the exponent. So m squared times m to the 4th is what? There's your answer. Okay. Now, we didn't really talk about this rule, so I'm going to throw it in there really fast. If you have a to the m power all to the n power, does anybody remember what you do? You actually multiply. So you get a to the m times n. Okay? So this is power to a power. That's what rule this is. Okay? So here, what's 0 times 6? Huh? Isn't it still just 0? Right? Anything times 0 is 0. And what's 5 times 6? 30. What's anything to the 0 power? So isn't it just 1? What's 1 times r? It's just r to the 30. Does that make sense? Okay. Let's look here. What do you think we're going to do here? Multiply what? 6 times 1. There's not technically a 1 there, but it's the same thing, so this just gets a 6. Then we do the x's. What's x squared times x? X to the 3rd power, x cubed. Then we have y cubed, but there's no y over here. So I just rewrite it, y cubed. But over here, I have a z squared. Did I have a z over here? So I just rewrite it. So anything that doesn't have a like term, I guess you could say, you just rewrite with your answer, okay? Okay, so over here, I want you to remember that anything without an exponent technically has an exponent of 1, right? So 3 to the 1st power, m to the 5th power, n to the 7th. So when I have an exponent on the outside, I multiply. What's 3 times 1? So this becomes 3 cubed. 5 times 3, 15 over 7 times 3, 21. What's 3 to the 3rd power? Okay, be careful, because I've had lots of people try to tell me 9. Okay, 3 to the 3rd power, might help if I turn it on. 3 to the 3rd power is a 27. I was about to say 9, even though I said it wasn't 9. Okay, because I want you to remember, exponents means that's how many times you're multiplying it. What's 3 times 3? Times 3? That's why. Does that make sense? So it becomes 27 m to the 15 over n to the 21. Okay, so look at number 11. What do you notice? I can tell you there's like 12 different ways to do this. Okay? We could make it big numbers, but then if it stays a fraction, it's going to be hard to simplify. Okay, what's the rule when the bases match and you're dividing? You subtract your exponents, right? You cancel them out. What's 5 minus 3? 2. What's 3 squared? There's your answer. Okay. If you would have done 3 to the 5th power and 3 to the 3rd power, you would have ended up with numbers that you couldn't just divide in your head. Granted, you could type it in the calculator, but you'd just be adding more work for yourself. Subtract the exponents, makes it smaller. There's your answer, okay? What do you think we need to do first on number 12? Huh? The power on the outside. Sorry, masks make y'all like muted. Okay, we need to get rid of this 3 and this 2 before we can combine across. Okay, so what's a to the 4th to the 3rd? Power to the power, what do we do? Multiply, so we get 12 over 5 times 3 is 15. I'm popular today. Okay, so then what's 2 times 2? 4. 2 times 2 is 4. Okay, so knowing that, what do you think we do next? We can put it all together. Because what with multiplying, wouldn't this just be a 12 times c4 over, well, remember, if I put it in order, it'd be a4 times c to the 15. Now what do we do? Divide. What's 12 minus 4? Huh? So we have a to the 8 on top because there were more on top. Now where are there more c's? Don't know what just happened. Welcome to Acrobat. I didn't even click on anything. Okay, where are there more c's? Bottom, so that's where the c is going to stay. What's 15 minus 4? There's your answer. Any questions with that? Okay, so there's a practice. I want you working on that. You have the rest of the period today. You don't have tomorrow, so you just have today. But if you have questions, oh, I did want to go over one of them with you, actually. Look at number 1. What's different about this one? It has addition and subtraction inside of the exponent. Do you think we treat it any different? No. So what's 3 times negative 2? Negative 6. Then we have the x as our base. And what do we do when we multiply? What do we do to our exponents? We add them. So I'm going to take y plus 1 plus 2y minus 3. How do you simplify that exponent? Just combine like terms, right? What's y plus 2y? And what's plus 1 minus 3? There's your answer. That's a 3, sorry. So it's negative 6 to the 3y minus 2 power. Okay? Did we treat it any different? No, it was just simplifying, though. Okay?